Okay, today we're going to talk about properties of logs. And this is going to be for these restrictions, and this just means that the log will be able to be evaluated. These properties will help you evaluate logs a little bit quicker. So the first property is if I have log with some base that we'll call a of 1, that is always going to equal what? Well, let's take a look at some examples. If I have the log 6 of 1, what does that equal? Or if I have the log 47 of 1, what does that equal? It will always equal 0 because any base raised to the 0 power is always going to equal 1. So anytime you have any log, I don't care what this base is, if you have the number 1 next to it, you know it's always going to equal 0. You don't even have to think about it. The second property we're going to talk about is the log a of a. Once again, let's take a look at some examples. If I have the log 3 of 3, or the log of 2.6 to the 2.6. If you put this in exponential form, it's like saying 3 raised to what power equals 3 to the 1. So you know that this is always going to equal 1. So there's your second property. Anytime your base and the number next to the base are exactly the same, you know it's going to equal 1. Now we have the log a of a to the x. Well, this is very similar. If we take a look at example, it's the log 2 of 2 to the third. This is like saying 2 raised to what power is going to equal 2 to the third. Or 12 raised to what power will equal 12 to the fifth. So here, this is always going to equal x. This one will equal 3, this one would equal 5, and this one here would equal 8. So anytime these two are exactly the same, whatever it's raised to is what it will be evaluated to. Your fourth property is if I have some number raised to the log that has the same base of that number of x. Again, let's look at an example. If I have the log if I have 2 raised to the log 2 of 8, well, if you evaluate this log 2 of 8 right here, you can see that this would be 3. 2 to the third is going to equal 8. So you can see that this simplifies down to 8. If I have another example here where the base and this base are exactly the same, if I evaluate log 3 of 9, that's going to be 2. 3 to the second power is 9, so this would simplify down to 9. So anytime this base and this base are exactly the same, it will evaluate down to whatever this number is right here. That's your fourth property. So if you have, for example, the 5 raised to the log 528, what will that evaluate to? 28. On your fifth property, you see you have log of some base b of a times the log of some base a of b. So you can see from this log to this log, your base and your numbers just switch. Again, let's look at an example. If I have log 3 of 9 times log 9 of 3, you can see here the 3 and the 9 switch onto this log. Let's evaluate this. Well, the log 3 of 9 is going to be 2, and the log 9 of 3 would be a half. 2 times 1/2 would equal 1. Let's see if this always works. The log 8 of 16, well, I can think of that as the log of 2 to the third times 2 to the fourth, so this will be 4/3. And the log 16 of 8 will be 3/4. Well, if I multiply 4/3 and 3/4 together, I still get 1. So anytime you have two logs multiplied together where their bases and the numbers switch, it's always going to evaluate to 1. So if I have the log 5 of 17 times the log 17 of 5, what will that equal? 1. Now, there is a corollary to this one, which is often forgotten, so you might want to star this one in your notes. If I have the log b of a, that's the same thing as 1 over the log a of b. For instance, if you just take this log right here and divide both sides by the log a of b, you can see it becomes 1 over the log a of b. This is going to be helpful in some things we'll be doing later when you need this, when you need these to switch. One way you can make them to switch is to put 1 over it. All right, so why don't you try it? Log 100 of 10 to the 6th. Well, if we look back at your properties, you know that if I had log a of a to the 6th, if these two are exactly the same, you know it would be 6. So we have to kind of think, how could we write these two so that they are the same? So if I have log 10 squared, well, that's still 100 of 10 to the 6th. So I'm getting closer. Now they both have a base of 10, but this is 10 squared and this is 10 to the 6th. But I could write it again as 10 squared of 10 squared raised to the 3rd. This is still 10 to the 6th, but now these are exactly the same, so I know this evaluates to 3. Right here in this step, you can also take a look at it, and it will always be, if you take 6 divided by 2, it will give you the answer as well. When you're doing this, you can go right from here to this step. You don't need to show me these intermediate steps. You will get good at these so that pretty soon you'll be able to see them very quickly. All right, 2 raised to the 3 log 8 of 5. Again, look back at your properties, see which one this looks most like. This looks like the one that is 2 raised to some log with some base 8 of some number. So if I could get this to also equal 8, then I know it would evaluate to 5. Well, if I look at this expression right here, 2 to the 3rd, well, isn't that equal to 8? So I could really rewrite this as 8 log 8 of 5. Now these two bases are the same, and I know this evaluates to 5. All right, log 2 of 4 to the 5th. Well, once again, if I'm looking at my properties, I know if these two are exactly the same, it would equal whatever this number is. So I really want to write this number 4 so that it has a base of 2. So why don't I write it as the log base 2 of 2 squared raised to the 5th? All right, 2 squared is still 4. I haven't changed the problem. I've just rewritten it. 2 squared raised to the 5th. Well, if I put those two together, that could be rewritten as 2 to the 10th. I have a power raised to a power, so I'm going to multiply. Now these two are exactly the same, and I know this evaluates to 10. 9 raised to the 1/2 log 3 of 6. Once again, I know if this base and this base were exactly the same, it would evaluate to whatever this number is. But if I look at 9 to the 1/2, I kind of recognize, well, isn't that really just 3? So 3 log 3 of 6, now I know that that's just 6. All right, I have 4 times the log 6 of 12 times 5 times the log 12 of 6. Again, it's always a good idea until you really know these. Go ahead and look back at your properties and see which one does this look most like. Well, this looks like the one where I had log A of B times log B of A, where these two are just switching. So these are really all multiplied together, so there's no reason why I can't just kind of rearrange it a little bit. And I'll put my 4 and my 5 together out here, and then here I have this log 6 of 12 times log 12 of 6. Well, I know this whole expression will evaluate to 1, and then I just have 4 times 5, which is 20. All right, let's try one more. I have the log 9, 3 to the 8th. Well, once again, I would really like these to be exactly the same. So I can write this as the log of 3 squared, 3 to the 8th. Well, we know a shortcut now that I can just really say this is 8 divided by 2, and I know this will evaluate to 4. But another way to think of it is to say the log of 3 squared raised to the 3 squared raised to the 4. Now these two are exactly the same, so this evaluates down to 4.